Okay, so let's go ahead and take a look at this proportion. Now, I realize that the first thing everyone's going to do is going to want to change those fractions to decimals, right? It's okay if you do in this case because they will come out to terminating decimals, meaning they end, they don't repeat. We don't want to work with repeating numbers because then we're rounding and we're introducing some error in there. But we can do this with these. So 2 1/4, remember you could take 1 divided by 4, that will give you your decimal. It's going to end up being 2.25. And if you take 3 divided by 8 to get a decimal, you're going to get 3.375. Okay, so we can use those two. So let's go ahead with width of the small one, which is 2.25 inches, over length of the small one, which is 3.375 inches. So now I have to do width of the big one. That's what I don't know. So think about what we can put in there. You can put in a variable, right? You can put in W or X, whatever you would like. And then the length of the big one is 6 feet. Now, in this case, we don't have to worry about the units being different because within each image, they're the same. So it's still going to have the same relationship here. You could change this to inches if you wanted, but as long as it's inches to inches, feet to feet, and they're not mixed within one image, that's okay. All right, so let's think about how we can solve for W. Some of you probably remember this, that this is what everyone always wants to do when they see fractions, which is to cross multiply. So one thing you can do is you can cross multiply, meaning that I multiply the numerator of one side with the denominator of the other. And then I do the opposite. And those two things are going to be equal. So I'm going to have 2.25 times 6, 2.25 times 6 equals 3.375 times W. And then we're going to use our algebra knowledge. So we're going to multiply these two first. So 2.25 times 6 is going to be 13.5 equals 3.375 W. And then think about our algebra from last time. I want to get W by itself. I'm going to divide by whatever's in front of it because I want one W here. Okay, so W is going to equal, let's see, 13.5 divided by 3.375 is going to be 4. Now, we always want to think about for what? So remember we were trying to find this width, right? And this was in feet. So the width is going to be 4 feet. Okay, so that's one way to solve that, is by cross multiplying. Let's just look at another way. Let's give you some options. All right, so let me just start out with what we have. 2.25 over 3.375 equals W over 6. So another way we can think about equivalent fractions, let's think about if we have 1/2 equals 5/10, right? Well, we know this is okay because whatever I do to one part, in this case multiply by 5, so in terms of multiplying or dividing, I do to the other part, and then that makes it okay. That makes those two equal. What I'm really doing here is saying, let's say I have a candy bar, I give you half of it. Okay, this is 1/2. Well, what if instead of halves, what if I had split it into 10 pieces? Pretend these are equal. Okay, and I had given you 5 out of 10 pieces. It's the same thing, right? Multiplying by 5 here meant the pieces were 5 times as small, but I gave you 5 times as many. So if I do the same thing to the bottom and the top, then that's okay. So I could think of this two ways. I could say 3.375 times what gives me 6? Or I could figure it out the other way. I could say if I divide this, what do I get? So 6 divided by 3.375 is going to be 1.7 repeating. Well, so that means that this times 1.7 repeating gave me 6. If I multiply that by the same thing, so the best way is to just leave it on your calculator, don't round it, and multiply that by 2.25, then I'm going to get 4. I multiplied the top and the bottom by the same number. So whichever method, feels better to you is fine. Okay, let's look at number 3. In question 2, you could have used the following proportion to represent the relationship between the original and the enlarged objects. So they do have the same proportion that we had. Let me just write it here. And they already plugged in the 4 for the W, right? So 2.25 over 3.375 equals 4 over 6. And the question is, could this proportion be written in other ways? And the answer is yes. Now, there are a lot of ways that would not be correct to write it, but there are some other ways that would be correct. So remember that I said that your proportions have to have a pattern. That's the important part. So here we did width of the small one to length of the small one, width of the big one to length of the big one. So generally here in class, we stop and we take a few minutes to figure out some other ways that you could have written that. So I'd ask you to pause the video and just think about some other patterns that you could have come up with. Okay, so one pattern that usually people see relatively quickly is I could have just flipped this. There was nothing over here saying that I had to write this on the top and this in the numerator and this in the denominator. So I could have put this on top. My pattern here would have been length of the small to width of the small. So now think about what the pattern has to be over here. Length to width for the small one, length to width for the big one. Or I could have said, this one's a little trickier maybe to come up with at first, but width to width. Width of the small to width of the big. And obviously if we were solving these, there would be a W or an X here instead of the 4. So width to width going from small to big. So think about what my other pattern would be. Length to length also going from small to big. So 3.375 over 6. Okay, and again with this you could have flipped those. You could have said width to width, length to length. The important thing is to have that pattern. I can't say width to width and then go the other way. So if this is going to be in the numerator of one, then this has to be in the numerator of the other, if I'm comparing that way. How do I know these are all the same? Well, think about this method, cross multiplying. If I have a proportion, if I'm not looking for something, I can still cross multiply, and what happens is that the cross products, the things we get when we multiply, have to be the same. So I can see, even if I don't actually do the work, I can see that I am multiplying 2.25 equals 6 times 6, and then I'm multiplying 3.375 times 4. Okay, and I would check that those are proportional because whatever I get here has to equal whatever I get there. Well, before I even do that check, when I look at these just to see if these mean the same thing, look at what I'm multiplying. 3.375 times 4, 2.25 times 6. 4 times 3.375, 2.25 times 6. So that tells me that these are all set up correctly because they're all multiplying the same thing. If by mistake I had said, okay, I'm going to start with this, 2.25 over 3.375, so I did width over length, and then over here I switch it and do 6 over 4, I'm not multiplying the same things. So this one is not correct. It's not set up correctly. Okay. So we found a bunch of different ways that could be written. If you look at number 4, one of those ways is there. Okay. It's this one with an X still in place of that 4. And this question is asking you to think about solving that proportion and what questions or what steps, sorry, would you use to solve that equation? So 3.375 over 2.25 equals 6 over x. So again, there are a couple different ways we could do this. If we're using cross multiplying, we know that we're going to multiply these two and we're going to multiply these two, right? So our first step, it does not matter which direction you go first. I generally tend to put whatever has an x in it on the left. So like this one has an x in it. And the other two on the right. And I forgot now what 2.25 times 6 is. 13.5. So first we cross multiply, set those cross products equal to each other. Multiply. And then what do we do next? Think about how we want to get that x by itself. Divide, right? So we get x, just 1x equals, and then that would give us our 4. And remember, it's 4 feet. Always think back about what your answer is. Okay. So now in 5 and 6, you have two proportions to solve. Okay. It asks you to round to the nearest tenth. So what I would ask you to do is pause the video and then go ahead and solve those two. And then come on back and we'll go over them. So actually I'm going to stop the video so that way when we start up again we'll have time to do the last 3 problems. Okay? If you're comfortable with 5 and 6, I would invite you to also try number 7. That one is the same idea. You're just writing a proportion now, which you're going to need to know how to do. So think about, again, that pattern.